right, so we are doing division part 2 with this unit. We're going to go in a bit more intensity with it. But lesson 10.1 and lesson 10.2 are about doing the same thing. And we're only going to briefly look at 10.1 and then move on to 2. And I'll show you why. One way that we do division is by doing repeated subtraction. Now, for me, there are 2 different ways to do repeated subtraction. The one in lesson 2 is a good way. The one in lesson 1, to me, is not a way that you should have to do to solve. It's one that we need to know about, because if anything, we need to be able to identify what it is and are familiar with how it looks. But it's not something that we are going to regularly use to solve. You'll see what I mean. So in this one, repeated subtraction, repeated means over and over, right? Yeah. Doing it again and again. So to do repeated subtraction with division, if I'm being asked to do 24 divided by 2, first off, I know you take one look at this and you immediately know. What it wants you to do is one version like this. Okay, well, I need to get 2 groups and I have 24 to do it with. So I'm going to put it into groups of 2, and I'm going to see how many groups I can make. One way to do repeated subtraction is like this. Okay, well, 24 minus 2 is 22. 22 minus 2 is 20. 20 minus 2 is 18. 18 minus 2 is 16. 16 minus 2 is 14. 14 minus 2 is 12. 12 minus 2 is 10 minus 2 is 8 minus 2 is 6 minus 2 is 4 minus 2 is 2 minus 2 is 0. When I hit 0, I'm done. I'm not quite done though, because now I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I was able to do this 12 times, meaning 24 divided by 2 is 12. That took way too much of my life away. I do not need to do this. But if I were to be given only this to look at, and maybe the question was, what division sentence is this repeated subtraction showing? I would then be able to say, well, the number it starts with is 24, so that must be my total amount. It keeps subtracting 2 from it, so it must be wanting me to do 24 divided by 2. There are 12 in all that take me down to 0, so that means it must equal 12. So that's the point of this. You do not have to do this to solve, especially with 24 divided by 2, okay? Here's an even better way. I say that sarcastically. Here's an even better way to do it. I want groups of 2s, right? And I only have 24. Okay, here's how I do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. How many groups did I make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my answer. So this is, but again, if you are just getting this, if all you get is just this random thing of dots with circles around it, you'll know what you're looking at, okay? There's a reason I'm still showing it to you instead of skipping it all together. Now, of course, 24 divided by 2, that is mental math right there. But if I were to solve this long division, it would look like this. First, can 2 go into 2?
Yeah.
Yes, one time. Because 1 times 2 is 2. 2 minus 2 is 0. Bring down that 4. Can 2 go into 4? Yes, because 2 times 2 is 4. And 4 minus 4 is 0. It's a much better way to do it. Now, look at these questions here. How many 5s are in 35? Tell me.
7.
How many 7s are in 84?
12.
12. How many 8s are in 72?
9.
So do we need, for this kind of stuff, how many 6s are in 66?
11.
We don't need to do this. When this is pretty much our multiplication facts, we don't have to go through this. If we're looking at this, it's a different story. But this is just one of many ways that you can solve division. Now, I want to go on to 10 too. You will. So 10-2 is the way that I prefer to do division with repeated subtraction. Remember when we were doing multiplication and we would break it apart because it was too big for our brains to handle?
Yeah.
Well, that's kind of what you're going to do here. When I am dividing, and it's with a bigger number that I can't just immediately make out a fact for, let's say 63 divided by 3. In my head, I can't quickly just come up with it. Now, I do know little tricks on how I can do this, but let's pretend I forgot those tricks. First, I ask myself, all right, how can I break this down and make this easier? You know what? What times 3 is going to get me close to this? 3 times 10, anything times 10 for this type of stuff is always a great place to start. But in this case, 3 times 10, that's 30. That's way too small. So what if I did 3 times 20? Well, 3 times 20 is 60. 63 minus 60 is 3. 3 times 1 is 3. So if I add up these two right here, 63 divided by 3 is 21. Let's try some more of this because this is the way I want you to do, okay? Guys, you will notice that the stuff you're getting right now in this is simple. A lot of it you'll be able to do in your head quite quickly. That's not what this lesson is for. The reason we're doing this lesson, and I am wanting you to do it the way I am doing it, is because you need to learn it, and you need to learn it easily. If you're learning to ride a bike, you don't just hop on and go. You got training wheels on first, so you get an idea of the bike, and then you take them off. We're going to do this with some easy problems so that when you come across the crazy, ridiculous, hard ones, you know your strategies. You know how to approach it. So let's look at 48 divided by 4. So here's how we write it. 48 divided by 4 equals. That's how I set it up. No matter what, I always multiply by 10 first. That makes it easiest. If it's way too low, I might go up to 20. But I don't want to go into 15s. Just 10s. That makes it a lot easier for me. So I'm going to start with multiplying my second number, my 4, times 10. And I put it in parentheses to show that it's not being multiplied by this number here. 4 times 10 is 40. 48 minus 40 is 8. How many times can 4 go into 8? 2 times. If I multiply 4 times 2, that makes it 8. 8 minus 8 is 0, meaning this is what I've got. I'm going to add these two together, just like we did in multiplication where you add up the individual ones. 10 plus 2 is 12. Okay? Let's try it again. 75 divided by 5. We write it like this. And then underneath, what's my first step?
10.
Times 10, always. Unless it is way too small and times 20 would make sense. In this case, times 10 makes perfect sense. What is 5 times 10? 50. Okay, what's my next step?
75.
Subtracting. 75 minus 50 is? Think of quarters. 25. 5 times what is 25?
5.
Uh-huh. And 25 minus 25 is 0. So now what do? Add my 10 and my 5. And that's my answer, 15. Let's try another one. 153 divided by 9. All right, now is when I look at this and my brain either goes totally know it or my brain goes, wah! Because this is a big number and my brain will freak out. You take baby steps. That's when we just, like, without even trying or thinking, just 10. Multiply by 10 and see where it takes us. So 9 times 10 is 90. Okay. 3 minus 0 is 3. 15 minus 9 is?
6.
Uh-huh. Okay. Now my brain sees something that makes it very happy. Because I went from like a crazy big 3-digit number to a multiple that I have memorized of 9. What times 9 is 63?
7.
9 times 7 is 63, and 63 minus 63 is 0. So now my answer is 17. So if you ever see something that you freak out about, just start at 10 and go from there.
Oh my God.
Okay, let's try one more. 65 divided by 5. Okay, what's my first step? Times 10. So then what do? I multiply 5 times 10 and write it underneath the 65. And then I subtract it. 65 minus 15 is? 65 minus 50 is 15. What times 5 is 15?
3.
Okay, so now what do? Add them up. 13. Now, one more thing I'm going to show you, okay? So let's say I've got 64 divided by 4.
Do we write this?
Yes. This is troubleshooting. This is what you do when you get stuck. So 4 times 10 is where I start. And that's 40. And then I subtract. 4 minus 0 is 4. 6 minus 4 is 2. If my brain shorts out and I forget everything I've ever learned in 4th grade and my multiplication facts have gone out the window and I don't know what I'm doing, then I can do as long of a little trail of subtraction as I need to. Maybe I can't remember that 4 times 6 is 24. Maybe I'm just stuck on that. I'm going to go with what I know. You know what? I know what 4 times 3 is. What's 4 times 3?
12.
I know 4 times 3 is 12, so I can do that and just go from there. 4 minus 2 is 2. 2 minus 1 is 1. Oh, okay. So there's 12. Oh, well, I just did that, so I could just do another 3, and then I'm good. So it does not have to be the exact. Like if you cannot remember that 9 times 7 is 63, go to a 5. Go to a 2. Go to a multiplication fact that you know. And then you can build up on that and just sort of, did this take me a little bit more time? Yeah, it did. Which means that, you know what, I need to brush up on my multiplication facts, but I'm still able to do this. Okay? Do we understand how to solve it this way?
Yes.
Okay. Very good.